correlation, that means you are trying to relate two things or more things, and regression analysis or linear regression we are going to do in this assignment. You all know the concept of linear regression, in which we are having two types of parameters. One is called as the response variable and another is a predictor variable, and we generally represent those in the form of a line equation, just like you have learned in childhood, y is equal to mx plus c or mx plus h. So where m is nothing but the slope, where here a is representing a slope and this b is representing your intercept, y-intercept. Okay, so here we can easily say that the y is dependent variable and x is independent variable. Okay, so this x is also called as the predictor variable and y is called as response variable. So now we are going to learn about three types of regressions. Very first is simple linear regression, in which if we have the history with us, history in the sense, if we have set of data, from that we are generating a regression model, which is nothing but finding out the values like this, these two values v0 and v1. So what they are, so just now we have seen y is equal to mx plus c. So this is here mx, m, and this is here h or c. Okay, so here x is independent, y is dependent, v0 is constant term or intercept, and v1 is coefficient of relationship between x and y. So we can say that if I am writing y is equal to 2x, so if x is 5, then y will be 10, is it? So this b1 2 into, so this b1 is indicating the coefficient of relationship between x and y. So in R, how we will be executing this? So you just go through all these details. You have given the answers already to me in last practical. So we are just directly going to the execution part. So experimental setup to establish regression. So a simple example of regression is predicting weight of a person when his height is known. To do this, we need to have relationship between height and weight of a person. So how we will carry out this? To carry out the experiment of gathering sample of observed values of height and corresponding weights. Okay, then create a relationship model using LM function. So in R, we are using which function? Linear model, we can say, or LM in R for getting the linear regression model. Find the coefficient from the model created and create the mathematical equation using this. So it is, again, R is very good language, as I have told you. No need of much of the programming. You just pass the parameters and you will get directly the result. The model will be ready without doing any much of the coding. So get a summary of the relationship model to know the average error in prediction, because this error decides whether your modeling is proper or not, whether whatever line you have identified is close to the other results. If minimized error, then we can say that you have you have regressed properly the two variables. Okay, so to predict the weight of new person, use the predict function. So once the model is created, then we will apply the predict function, which will give us for new variable value. So how we will execute this? So very first, we are considering there is a input data, that is values of height and values of weight. Okay, then we will be applying the LM function. So better we get it and go to. So see here, using two vectors x and y. Okay, where x vector is indicating what? See here. So x is indicating your height and y is indicating your weight. Okay, so I'm just copying it to the R. So let us first clear it. What I've done with this, I've created two vectors representing weight and height. See what is X and what is Y. Okay. Now we are going to create the model. Okay, linear regression model. How we will do? We will apply the LM function. Now, where here is a comment, apply the LM function, and we are creating a model into the variable known as here relation. I can give any name. Now this is a LM function. Now what is given input here? Here this y tilde x, where what type of relation we want? We want relationship between x and y. Okay, where y is a dependent variable and x is independent variable. So this command is executed and their relation is created. Now how we will verify the relation is created? We will print the relation. Now we will see what information it will print if we will ask it to print the relation. See, here the formula used for regression is y tilde x, that is y is dependent on x. So find out their relationship. Okay. So after applying this linear regression model, automatically it has created the two coefficients b0 and b1. So this is here b0 and this is here b1. Okay. So here this is actually your m and this is your h or c. So these two coefficients are given by this relation. Now using this relation we can find out value of y for any value of x. Okay. So now how we will do it? We will apply the predict function. So we have got similar results. Now if we will print the summary, we will get more details about the relation. So here, this is the formula applied. In summary, we get how many values? Minimum, maximum, median, first quartile and third quartile. All the information is given about the dataset. These are the coefficient. The standard errors are also shown. So all these details are related to the regression. Next, we want to predict the value for any new x value which is not available in this data set. Okay. So from this history, we want to, what is the history now? This x and y values. From this, we have find out the model, regression model. And then we are interested in finding out if the x value is, for example, here 170. Then what will be the y value? Applying whatever model is created using this function. Okay, so we are directly applying this because we have done till above in earlier case. So now we are interested in finding a weight of a person with height 170, which is not available in given data set. So how we will do it? So we will be having data dot frame. So we are converting the information of x into data frame form. Okay. So and value is 170 is assigned to A. Now result is assigned what is predict and relation comma A. So relation is the model which is generated already by using existing y and x value, and to this we are giving this A value in which the x value is 170. Now we want to print what is the result. See here, the result is 76.22. So what this indicating? If the person weight is 170, then his height can be, sorry, if his height is 170, then his weight will be 76.22. So likewise, you can now predict. Now, what are the application of linear regression? If some linear relationship is existing between two variables, then very first, what are the coefficients of those relationship we can find out, we can model it, and then we can predict. So we can finally conclude that linear regression is used for prediction purpose. Okay. Now I hope this is clear to you. Have you understood? Is it clear? Yes. Okay. So now we are moving to next one. Next type of regression, that is a multiple regression. So in before going to multiple regression, we can go for plotting. So for plotting the chart, we will be using this command. So plot function, you have already learned about plot function. So in this way, you will get the plot. So let me first once again print the value of x and y. So this is our x, this is our y. Now here the regression line is generated from this existing values. So here on x-axis we are having weight, and on y-axis you are having, am I right? Yes, height. Okay. So now every point is plotted. See here, 151, 151 and 63. Okay. So like this, these blue dots are indicating all the 10 points. See 2, 4, 6, 8, 9 and 10. Is it? 4, 6, 8 and 10 points. Here also there are 10 points. So these 10 points are plotted, and this is the approximate line. Okay, so AB line LM, this function is used here to draw this particular line. So this line equation will be having what intercept? Just now we have seen. So minus, so if you will take this line to the uh, downside, it will give you that kind of intercept, y-intercept, and this is the x-intercept. So if you will apply this formula, then or we will try to check out whether we are getting close values or not. So just now we have seen for 170 value, we got the value as 76.22. Now by using this, so just remember 60.67 and minus 38.45. So we will write, suppose y1 is equal to minus 38.22 plus in bracket, is it, or what it was, 4 5 and 6 7. Okay, 38.45 170 into was 0.67. So it is very close. So if we will take all the values, you will get, so if you will find these are closely matching. Okay. So by using those intercept B0 and B1 coefficients of linear regression model, you can predict the value of Y for any value of X. So now we are moving, and in this way you can find out the line of regression, linear relationship between two variables. Now, if we have the relationship for multiple things, see, if you will write like this, you will get another line, interchange in the height and width. So in multiple regression, your y is dependent on not only on a single x, but it is dependent on multiple x. Okay, so again, we will take the example, which is a data set which is available as soon as you um, install the R. So with this, we are trying to get the information. Here, so this is a empty class, which is a or data set which is already available as soon as you install the R. So no need of installing any extra packages or getting the libraries. So from this data set, you are trying to get. So there is a nothing and comma, and there is a something which is written inside a vector. So what it indicates? So out of existing multiple columns from this data frame, you want only this many values for all the rows. Okay. Now here the head function is used. You have already used this in third assignment. So with the head, what is happening? You are getting top 6 rows, right? So here you can see here multiple cars, first 6 cars details with their different details are available here. Next, so we have also got similar kind of values. Then we are trying to create the relationship between these two uh, or existing multiple variables. So let me copy whole thing. So here, create the relationship model. Model is equal to LM. Now this we want to consider MPG as a dependent variable and display HP and weight. All these three are considered to be the independent variables. Okay, and we are taking data from the input. Okay. Now, after applying, we will be getting a model. Now, after showing model, it will show us the details. What are the details? What formula is used? This formula is used. And what intercepts we have got? We have got 37.10 as intercept. And other B0 is this. And B1, B2 and B3. These are the three coefficients corresponding to these three independent variables. Okay, so we have got the model. Now we want to use this model for, so here what is done is this coefficient values are also assigned. Let me copy and paste it. So with this, what we have done, get the intercept and coefficient as vector elements. So CAT is concatenation. Okay. So get, this is the comment. So whenever you are displaying the output, okay, and there's a backslash, give a one line. Okay. So like this, it will print. Then coefficient model 1. is assigned to A. Okay. Now here it is printing. So this is print A. A is having what information here? First coefficient, this one. Similarly, coefficient model 2 is having this, 3 is having this, and 4 is having this. So these all are stored in this different variables, and if you will print, you will get the similar values here. Okay. So can we say our model is ready? Yes, our model is ready. So if we want to predict the value for this dependent variable, which one is this MPG, then we have to provide some values for these three parameters, and this coefficients will be taken from this model, and you can predict the value of the MPG. So if we apply the formula like this, so we are see, based on above intercept and coefficient, we create the mathematical equation as A plus x display 1 dot x1. These are the variables just now we have stored here: x display, xhp, xwt. Okay, so and dot x3 is indicating multiplication of x3 value, x2 value, and x1 value. So here the sample formula is given here. If you provide the value of x1, x2, x3, so this formula will give you the dependent value of, that is, y. So if we want to give this information, displays this HP is having this value and the weight is having this value, then applying formula, we will be getting the similar value. So actually we want to apply this formula, providing x1 as this, x2 as this, and x3 as this. So I think there is no need of much of the discussion on this. You can try easily all this thing, and you can predict the value of y. So this is happening in multiple regression, where the dependent variable is dependent on multiple independent variable. Now we are moving to the next type of, do you want it to be done for some value? I can use any value here and just putting the values. Now in a logistic regression, we are getting a special kind of responses. See here, the logistic regression is a regression model in which the response variable, that is a dependent variable, has categorical values such as, what do you mean by categorical values and continuous values? Continuous values means any numerical value which can be anything. Okay, but when we talk about categorical value, means either male, female, true, false, 0, 1, some particular value, the your blood groups where you can't have any middle values, okay, which is having some meaning. So that are called as continuous, but categorical values are the fixed values. So it actually measures the probability of binary responses. Okay. So if this will be situation whether, suppose the students will respond or not. So when such type of decisions or predictions are expected, that time we are using the logistic regressions. So here logistic regression is having categorical values such as true, false, and 0, 1. And the mathematical equation is in this form, okay, where y is the response variable, x is a predictor variable. So here multiple predictor variables can be there, x1, x2, x3, and a and b are the coefficients which are numeric constants, this a, b1, b2, b3, all this. So in R, what is the function? In R we are using GLM. See, this GLM function is used for logistic regression. Now we will see the example. So in the inbuilt data set, empty cars, just now we have seen, describe different models of a car with their various engine specifications. Okay. In empty cars dataset, the transmission mode, automatic or manual, is described by the column AM, automatic or manual, which is a binary value 0 or 1. We can create a logistic regression model between the columns AM and other three columns, example HP, weight and cylinders. Okay, so now here we are again getting the input for this. Okay, so let me make it bigger. Control L. Okay, so here you can find out these three values are continuous values. They can have any value from any numerical values. But here if you will observe this column, here AM is indicating 1 or 0 value, where 1 is indicating, just now we have seen what 1 is indicating. 1 is indicating the manual, while 0 is indicating automatic, right? Now we want to apply the logistic model. So how we will be creating this? So we are using this formula. For this, here GLM formula is AM is dependent on these three parameters. Okay, data we are taking from input, just now we have assigned input some value, family is binomial. So it is again a very deep study. So when you will learn data mining in detail, or that time we'll find there are different families in which we can regress the data set. Okay, so here we are using the binomial, and uh, this model will be stored. It's detailed in the am.data. If you will print the summary of this, see here this formula is used. Here again the summary. These are the coefficients. Okay, with the error z value, p value. Okay, now here significance code is used for 0, 3 star, 0.0001, 2 star, 0.01, 1 star, 0.05, dot and point 1 is blank, like this. So here from this observation, so dispersion parameter for binomial family taken to be 1 here. So here from these observations, what we can conclude. So let me discuss. So when we execute the above code, it produces the following result. We have just seen the result like this only. So from this, what are the observations? So in the observation, as the p value in the last column is more than. Now where is the p value? See, this is your p value in the last column. This is the last column. You observe this value. So it is 0 0.01, 0 0.64, 0 0.08 and 0 0.02. Okay. So out of this, if we consider this case, so these two values are greater than 0.05. Okay. So they are not taking so much of part in deciding the predictor variable, or sorry, response variable, that is dependent variable, while this 0.02 and this is 0.01. Now this is an intercept, so this is not considered here, but here since we are trying to find out of this which is the parameter which is more closely correlated with the dependent variable. Okay, so here 0.02. So if you will find out from this, if it is 0.01, then it is a star. Then 0.01 and 0.0.5. So here this is also 0.02. So from this, these two are discarded, and this particular parameter, which is corresponding to weight, is uh, playing important role in deciding the dependent variable, that is AM. Okay, so as the p-value in the last column is more than 0.05 for the variables cylinder and HPV, consider them to be insignificant in contributing to the values of the variable AM. So only weight impacts the AM value and in this regression model. Okay, so here from this observation you can see, so again see here, if we again check the data set, so here see it is 6, it is 6, still we are having 1 value and 0 value. For this 6, again 0 value. So these values are not deciding the value of AM. Now if we will look at this, HP is 110, here also 110, okay, it is 175, okay, still you are getting, for 110 if we will consider, we are getting both the values 1 and 0. Okay, but if we will observe this weight, here for 2 point and here 3 point, so we can easily categorize these values and these values which are correlated with the values of AM. So from this model itself, again it is clear that the weight is impacting the decision of whether it is a automatic or manual. Okay, so in this way you can execute the logistic regression model. If you are interested, you can go for more literature on the net, but as of now for this assignment we have tried to find out the correlationship between the variables or parameters in the given data set, and also identified the linear or some other type of relationship existing between them.